All right, this video is about being able to factor completely. So this will, a lesson will follow after this that gives you some practice with this. So let's look at some examples to help you along the way. So now, up to now, you've learned how to do specific types of factoring, all the different processes depending on what kind of polynomial you are given. And so now it's just putting it all together and kind of following a system to be able to make sure that whatever polynomial we're given, we're able to factor it all the way. So first example, it'll say factor completely. And so we're going to have ABC plus BCD plus CDE. Now, every time we're given a polynomial, our first step, always and forever, is to look for a GCF, or greatest common factor. So we look at every term. In this case, there are 3 terms here that we're looking at, and we're seeing if there's something in common that we can pull out of all of them. And so if we look at this, they all have a C in them. So we're going to pull a C out to the side. Now, what's left over? So let's look at that first term, ABC. So if I pull C and divide C out of there, I'm left with AB. The second term, BCD, if I divide a C out of there, I'm left with BD. And if I pull a C out of CDE, then I'm left with a DE. If I look at this, there's nothing else I can really do because I don't have anything that's squared. At that point, that's when I look for other types of factorings. So this one, all I could do was factor out a GCF, and so that would be the final answer. Let's look at the next example. A squared plus 12a plus 35. Okay, so we look for a GCF. In this case, I don't have anything that is common in all 3 terms, but I do have a squared term, an a to the first term, and a constant. So in this case, I probably can factor this into 2 binomials. Now, in the way to do that, we first look at we look at the first term and we say a squared. So what times what gives me a squared? So we know a times a gives me a squared. Then we look at the last term, 35. And so we look at factors of 35. What multiplies to 35? So we have 1 in 35. 2 doesn't, 3 doesn't, 4, 5 times 7. And that's about it. So we have to say which ones of these are going to add to 12. So does 1 in 35 equal 12? No. Does 5 and 7 equal 12? Yes. So 5 and 7. And notice these are both plus signs, so that's what dictates these plus signs. So a squared plus 12a plus 35 factors into a plus 5 times a plus 7. Next example. 8c squared minus 26c plus 15. So in this case, we look for a GCF first. Notice there's nothing in common out of all 3 that we can pull out of there. So we most definitely probably want to try to factor it into 2 binomials again. However, this one's a little different than the last one in that we have a coefficient in front of the c squared. So that changes things up a bit. So in order to figure out what numbers we have to know that those numbers are going to dictate what we get in the middle. So remember, the outers and inners make the middle when we were foiling. Remember, we're doing an unfoil at this point. So we have to look at factors of 8, and we have to look at factors of 15. And we're going to look at a combo between them so that we end up subtracting or adding to a negative 26. All right, so factors of 8 are 1 and 8, 2 and 4. Factors of 15 are 1 and 15, and 3 and 5. And now it's just a matter of kind of playing the game as far as trial and error to find which ones work. So I tend to start with the smaller numbers, not the extreme numbers. So the 2 and the 4, maybe the 3 and the 5. So for C, 8c squared, that's where we get 2c and 4c. And then for the 15, we have 3 and 5. Now, what do we need to do? Well, we need to test this to see if it works. So our outers and inners. So we go back to our foiling game, and our outers and inners combine to give us that middle term. So our middle term, let's see, we have 2c times 5 would give us 10c, and then 3 times 4c would be 12c, and if I add those together, 10 plus 12 gives me 22. So that doesn't work. However, that doesn't mean all is lost. Remember, combinations work a little bit differently, so that we also have to look at rearranging one of them. So even though I put 2c, 4c, and then the 3 and the 5, maybe the 3 and the 5 need to be in opposite places. So we have to try those too. So now we have the 2 times the 3 gives us 6, and the 5 times the 4 gives us 20. And if I add those, I get 26. However, don't forget the negative. So what signs are they? Well, it's negatives in here. So what is our final answer? 2c minus 5 times 4c minus 3. And there's our factoring. Let's look at another example. 64t to the 6th minus 4k to the 8th. All right, so we look to see, yes, we could pull out a greatest common factor in this one. In this case, we could pull out a 4. If we pull out a 4, we might have to go to our calculator to see what 64 divided by 4 is. And we get 16t to the 6th. And if I divide a 4 out of the second term, I'm left with k to the 8th. We could have left it in there as well, because sometimes we have special factorings, and that's what this one is. Our middle term is missing, so that's one key indicator. Also, if I look at the coefficients and if they are perfect squares, meaning I can take the square root of that number. So 64 can take the square root, right? I have a number times itself that gives me 64. Same with 4. And so in that case, it becomes a special factorization. So I can pull the 4 out. I will get the same answer. No problem there. But I also want you to notice the special factorings. So in this case, it'll still be 2 binomials, but our middle term is nothing, so it's 0. So that means when I go to do my outers and inners, one is plus, one is minus, because it adds to 0. And for that to happen, they need to be the same exact amount. So that's why I said the perfect squares. So 64 is really 8 times 8. T to the 6th. How do I get t to the 6th? The same thing. So it's t cubed, t cubed. And then, let me clean this up just a little. Okay. And then we look at the second term. So 4 is 2 times 2. And then k to the 8th is going to be k to the 4th, k to the 4th. So I didn't give myself much room in there. Let me rewrite it. So we have 8t cubed plus 2k to the 4th times 8t cubed minus 2k to the 6th. Why did I write 6? I meant 4. Let's try that again. Okay. Now, we look to see if these can keep going. So it could be that we can keep factoring stuff out. Now, in this case, let's look at the first one. Is there anything common I can pull out of there? I can pull a 2 out of there. So I'm left with 4t cubed plus k to the 4th. And the second one, I can pull a 2 out of there, and I'm left with 8t cubed minus k to the 4th. And notice we have a 2 times 2, so that's where that 4. So we pulled out a 4 at the very beginning, and I said you could do it that way. You can most certainly do it that way because it comes out in the end, as you see. This should not be 8, it should be 4. I was going too fast. 4t cubed minus k to the 4th. And that would be our final answer. That's as far as we can go. Last example, x cubed plus 6x squared minus 4x minus 24. Okay, so this one's a little different in the fact that we have 4 terms. So anytime we have 4 terms, what we try to do is factor by grouping. So what does that mean? That means I want to group it in such a way that I can pull something out of each group. So I could definitely group them like this. And as long as I have something common I can pull out of each group, might be the way to go. Sometimes I might have to rearrange the terms in order to get those groupings to work. So the first term we can pull out an x squared. And so if I divide x squared from x cubed, I'm left with an x. If I divide x squared from 6x squared, I'm left with 6. The second one, I can pull out a 4, and I'd get left with x minus 6. Now what we want to look at is our new parentheses, do they match? Because they're supposed to, and they almost do, except for the plus and the minus. Here's what happens. Notice when I group them, I can kind of see that I'm already going to have that issue with a plus and a minus. So what happens is when I go to group this sounds a little interesting. Okay, so it's going to change the way this one looks. Is that I'm going to group it so that the minus sign, so I'm going to change it to a plus and negative, which is the same as subtracting. Now, why do I do that? Well, what happens is when I pull this out, I'm actually going to pull out as the common factor a negative 4. If I divide negative 4 from negative 4x, I'm left with a positive x. And if I pull a negative 4 from negative 24, I get a positive 6. Now they are alike. And that's what I'm looking for. So there's one binomial. Where does the other one come from? Comes from what's left over. X squared minus 4. Now, we're not done because we always want to see, can we keep going? And in this case, most certainly we can. What we want to do is x plus 6, there's nothing to do, but this guy looks like a special factorization. Middle term is missing. Coefficient of 1, 1 times 1 is 1. Constant of 4. 4 is really 2 times 2. So this one can be x plus 2, x minus 2, like how we saw before in the previous example. So our complete factorization is this. X plus 6 times x plus 2 times x minus 2. All right, that's it for this video. If you'll give me a call, and we'll talk about this video and answer any questions that you have. This will definitely help you as well with the lesson that follows. Have a great day.